Afternoon, everybody. Um, so my name's Dr. Peter Moult, and I'm going to be presenting today a project that we've been working on over the last couple of years. Or it's probably longer than a couple of years, actually, on co-creating laboratory classes and improving the employability skills within our life sciences students for their journey into the life sciences sector. I'm joined as well by a student collaborator, or a student collaborator at the time. She's now gone on to work at Imperial College. That's Miss Hanne Krogsaeter. We'll both be available and happy to answer questions at the end of the talk. So if you have anything, please just let us know. So really, this is based around a couple of problems that we've had, okay, over the years. We've got undergraduate laboratory practical classes that are sometimes a little bit paint by number, and they don't involve much to represent the changing employability skills required by the sector that our students are likely to be going into. We've also got this emerging problem over the last couple of years of increasing student numbers. Well, that's not a problem, that's a good thing. But decreasing resources and decreased capacity to be able to offer wet investigative projects. So more students, fewer wet investigative projects for those students that would like to do them. And finally, the wider sector has been suffering over the years from decreased participation in STEM subjects. And even those graduates that have participated in STEM subjects, when they graduate, the feedback from employers are that a lot of these graduates perhaps don't possess key skills demanded by employers, or that those skills haven't kept up with the demands of the sector at the time. And there's a fair bit of evidence to support those claims, and I've outlined those here. So what I'm hoping to present today is something that we've been working on the last couple of years that has set to, we started off by addressing point one, but we've evolved it to hopefully address those other two problems as well. Now, I appreciate that not everybody in the audience has a science background or a life sciences background, so I'll keep the science to a minimal, but I think what I'm going to discuss can be extended and expanded across the sector, whatever your background. So what we've done recently is to address this first problem is just designed new level 3 laboratory classes to be a little bit more authentic and to represent a little bit more like what a research environment would be rather than this sort of paint by numbers approach, i.e. we give you these instructions, you follow them, and you get this known answer. And one of the practicals that we've brought into the level 3 of the neuroscience degree recently is this neurophysiology lab where we're looking at the autonomic control of the heart rate of these little guys here, the Daphnia or water flea. And what we get the students to do is ask the question, do these represent a reasonable model or a useful model to study the autonomic control of the heart? So what they're really asking is, is the heart of this little water flea under the same physiological control as humans or mammals? And they design their experiments. We give them some guidance. We give them a number of pharmacological tools so they can probe this preparation and come to a conclusion. There's not a known answer, and it's not necessarily a clear cut and defined answer. And that's good because that represents what they will go on to do in a real research setting. Crucially, it makes them think and it makes them think critically. We've built on this, and the way we designed this lab is we got student input. So we took final year undergraduate students. Remember, the lab I've just described is a level 3, a junior honours lab. But we took level 4 students, and during their final year honours project, what we did was we actually started experimenting with these models. Um, and they initially approached it as a research problem with in the back of their minds the fact that they were also thinking about this in terms of designing it and creating it into a potential level 3 lab. So what we have done here is we have created this lab through our undergraduate level 4 students performing this research and this investigation as a final year project. So again, that gave us a few additional wet projects. Doesn't really address the shortfall in capacity in total, but it starts to address that question. It also crucially enables the students to be involved in the curriculum design of their own course. And as we know, because that's what the session is all about, this co-creation of the curriculum with the student partners fosters a much greater sense of ownership and belonging to the course. And it's been widely linked to positive outcomes in terms of professional development and employability skills. And that's that third problem that we addressed in the previous slides. And there's multiple sources I could cite for this, but these ones down here are quite a good read and highlight that particular problem. So we've used our level, well, not used, we've collaborated with our level 4 students in order to develop this lab. We have then run this lab, and we've run it for a couple of years now across level 3, and we've garnered some feedback from our level 3 students and, crucially, our level 4 students. Now, the level 3 feedback is not great, to be perfectly honest, when we look at our EVSIS scores for this practical each year. They quite often say we would like some more certainty with this practical. They don't like the fact they haven't got these step-by-step instructions. They can see how this lab links to the skills tracker, so we track these skills with our Royal Society of Biology skills tracker, so that's a good thing. They don't think they've got enough time to do it. They do like that the students have helped design it. This or variations of this come up quite a bit. The lab doesn't really work. The data's messy. It's hard to write up. There's not a clear-cut answer or variations of that, and they really don't like that because they're used to just having things that work with clear-cut answers. And to be honest, we kind of designed it like that because we didn't want a clear-cut answer because we wanted them to think. Some of the level 4 feedback, and the level 4 feedback is generally more positive than the level 3 feedback. And you ask them to reflect back on what they did, and this is during or after the level 4 projects that they're doing. I now see why we did the Daphnia lab. Okay, it really liked that I'm contributing to my own degree course if they're designing this course. And quite a few of them said, yeah, really sorry for moaning and the poor feedback that we gave you in level 3. Can kind of see why we did this now because we're doing our level 4 projects. And that doesn't always give us a clear-cut answer either. So they can see the relevance and they can see the skills that they've learned and they've translated into their level 4 projects. So this is good. Crucially, and I won't go into all of the details of all these different practicals, it's really scalable. So what we intend to do is to take groups of 3 or 4 students, run them as a group project, but we could have 4 projects going in a lab at a time. So you could have up to 12 students working on these projects. And we've got things ongoing on locomotion here using tadpoles. We've got some electrophysiology stuff going with cockroaches, and we've got some virtual reality things that we're working on here. Okay. So the plan is to run this start this year as a big group project. And what it does, it allows us to expand our wet investigative project provision with minimal increase in staff resources. It allows us to massively upscale what we're able to do in terms of collaboration and curriculum design. And it allows us to constantly evolve our practical provision at level 3 because we've then got this sort of production line going of different practicals. Dress this up into a fairly basic cycle, but what we're doing is taking employability skills, we're mapping them into honours project design so we can design these projects to match those employability skills. We're running them, and then we're linking them to assessments. So we're assessing their skills as we're going along. We're embedding them, and then we're feeding back, and we're hopefully producing graduates over here that are going back into the sector and have the appropriate employability skills. So hopefully what we've done is address this life sciences practical lab class issue. Some of the capacity issues we have with wet investigative honours projects, and also some of the employability skills shortages that we highlighted earlier on. So this project is ongoing. It's in its early stages at the moment. It's in collaboration with Imperial. That's where Hanne is now. Also, colleagues in life sciences, Dr. Leanne Mackay, Julie Myrtle Burgonyan, and Sarun Savicate, and Miss Marie Bowers, who is collaborating with us across Glasgow and Aberdeen because we're trying to run this across. So thank you very much for your attention. If there are any questions at all, we'll be happy to take them now. Thank you.